Okay, good evening. We're on once again to our WAEC NECO revision class, especially made for grade 12 students who are writing WAEC NECO this year 2022. And you can also have this as reference resource materials to prepare for other examinations in the future. This is a Mamu Jarvis experience, and we'll be trying to look at questions from 2019 June examination. And so we'll go straight ahead to look at question number 1. Now, question number 1A says, given that it's a test of your knowledge of what? Number basis, fine. So this will be equal to 40 base 5. Now, we're told to find x. So how do we look for x? We're taught a very simple technique back then. I'm moving from base to solve this. I need to make both problems to appear in base 10. So I have to convert both of them to base 10. Now, there's this technique we learned. We just put to tell us how we're going to arrange the expansion method we're going to use, and we have 0 and we have 1 here. So this will be the number times the base raised to the power of 2 plus the number times the base raised to the power of 1. And this, remember that when 0 multiplies anything, it is 0. So it's not important for me. So I will forget that. And then I go to the next one. This will be 0 times. So this will not also be important for me. So I'm going to have 4 times the base raised to the power of what? 1. So look at this. What I'm going to have will be what? X squared plus x equal to what? 20. Because 5 raised to the power of 1 is 5. Take note of that. 5 multiplied once. Okay, if that is settled, we're going to have x squared plus x minus 20 equal to 0. So we're bringing it to a pure quadratic equation format. Now, if that is done, I usually use my technique, sum of factor, which you see in my other videos. I've done serious work, especially if you go to my playlist, grade 9 and grade 10. I've done extensive work on this. So sum of factors will be 1, and the product of factors will be negative 20. Now, this is odd, this is even. It means the factors I'll be looking for must both, one has to be odd and the other has to be even. So I know if I'm going to break 20 to give me values that will give me 1. And because I have been in this business for a while, I know that 5 and 4 will suffice. I have a negative here. I have a positive here. It means that the bigger number has to be positive and the smaller one has to be what? Negative. So I'm going to replace x with these two values. So I'm going to have x squared minus 4x plus 5x minus 20 equal to 0. It doesn't matter which one you place first, you still get the same result. But by way of experience over the years, I always put the negative before the positive for something I'm trying to avoid. Now this will give me x into x minus 4 plus 5 into x minus 4 equal to 0. So from this, I have x plus 5 into x minus 4 rather, into x plus 5, and this will be equal to 0. This will be equal to 0, and that means x will be equal to 4 or x will be equal to negative 5. So that's the answer you're going to get. But remember that in this setup, because we are dealing with a base can never be negative. A base cannot be negative. So if we know that the base cannot be negative, it follows that x must be a positive value, and that x will be equal to 4. And that helps us to clear out question number 1A. Okay, so we'll try to look at exercise. We'll look at question 1B. Question 1B. In question 1B, we are testing our knowledge of salts here. So we have 15 over the square root of 75 plus the square root of 108 plus the square root of 432 or 432. So what do you do in solving this? Now, there are different ways you can use to handle this. You can handle this problem, but I always try to simplify the problem when I'm solving them. So what do? Look at this. If you look at this one, please follow me closely. This will be 25 times 3. So let me break them out so you can see what's happening in my mind. 25 times 3 plus, let's break this one out. By experience, I know this is, I can see 4, or I'll break this to a perfect square, which will be what? 36 times 3. This using the concept of perfect square and another number. Now, for this one, 144 times 3. 144 times what? 3. So, what I'm going to have here will be what? 15 over 5 root 3 plus 6 root 3 plus 12 root 3. Now, I'll take care of this. This will simply be what? 5 over root 3 plus, I can add this up, 18 root 3. I will then carry out a process called what? Rationalization of sorts. So this will give you 5 root 3 over root 3 times root 3. Plus 18 root 3. So this will give me what? 5 root 3 over 3 plus 18 root 3. 5 root 3 plus 18 root 3. So if you look at this, we can actually add this. And we're going to have 5 over 3 plus, let's see how the answer is presented to us. Okay, 5 over root 3 plus 18 and what? Root 3. So I can simplify this to one number.
Mr. Jarvis,
yes.
if you check, when you have that 15 over 5 root 3, 5 into 15 is 3, not 5.
Okay, so let's correct that. That's a very good observation. Now, you discover that what we have here is 3. Oh, fine, that's very good. And like I always will say, these are the little errors you can make in an examination and could ruin your exam experience. Because while solving, I was wondering why the examiners will want to put me through all those trouble. Thank you very much. I have a learning assistant in this particular series, so you would you pardon me that I have somebody who prompts me when I'm making an error, just to create that real life examination scenario. Okay, so with that, this will cancel this. I'm going to have root 3. So I will then clean this. I will clean this off. And what I'm going to have, so you can take this one off. And it's going to be what? Root 3 plus 18 root 3. So that will give me what? 19 root 3. And somebody will be asking, the coefficient, borrowing from your knowledge of algebra, the coefficient of root 3 is 1. 1 plus 18 will be 19. And that's how we're obtaining 19 as our final, 19 root 3 as our final answer.